Hi, in this video we're going to learn the basics of Amazon's VPC, which stands for Virtual Private Cloud. Before diving into the topic, we'll start with a quick introduction to data networking fundamentals. We're going to cover data networks, network addressing, private networks, and IPv4, which is the main addressing system that the internet uses. Let's start with what data networks are in general. A data network is a communications network in which every node can exchange data with each other. So in a data network there must be nodes, links between the nodes, and data that flows between the nodes. The internet is an example of a data network where an enormous amount of computers send data to each other. Okay, next we have network addressing. Each node of a network should have a unique identifier. For instance, we could assign numbers to the nodes. If node 15 wanted to send some data to node 20, then it would address the data accordingly, including the sender address, so that the receiver can send a response back. Private networks. When you're browsing the web, you're sending data to a server and getting a response back. Your computer is normally connected to the internet via a router, which creates a private network where you might have other devices like a printer and a phone. The purpose of a private network is to hide your private devices from the public internet. For instance, you wouldn't want anyone outside your private network to access your printer. So a private network allows traffic inside to remain private, but you can also expose certain nodes to the outside world. IPv4 Insider. One of the most used addressing systems is called Internet Protocol version 4. In this protocol, each node has a unique address, which is a 32-bit long number, for a total of over 4 billion unique addresses. We normally use decimal notation instead of the binary number. We divide the address into 4 groups of 8 bits and convert those to decimal. Some address ranges are reserved for private networks, so you will only see addresses from these ranges when two nodes are communicating within a private network. CIDR stands for Classless Interdomain Routing. That's a mouthful. It's a way to concisely describe a range of addresses. The notation has 2 elements, the first address in the range and the range size. The bigger the range number, the smaller the range of addresses, and vice versa. Okay, let's talk about VPC. We're going to cover the fundamental parts of a VPC. The VPC itself, subnets, internet gateway, route tables, security groups, and network access control lists. A VPC lets you create your own private network in the cloud, where you can deploy AWS resources. Every AWS account comes with a default VPC, but we're going to create our own. The only 2 things we need to decide at this stage are the VPC name and the range of addresses available. For the range, we'll go with 10.0.0.0/16, which is all of the addresses from the first one, 10.0.0.0, all the way to 10.0.255.255, which is a lot of addresses. Right, we're in the AWS console, going to navigate to VPC, and then click on your VPCs, which lists all the VPCs available. Create VPC, and we're going to call it my VPC and give it the address range that we discussed earlier, 10.0.0.0/16. Hit create, and that's pretty much it. We've got our new VPC. It doesn't do much yet, but there it is with our range. And notice that the default VPC for the account is there. It's marked as the default VPC. So now that we have our VPC, we're going to create subnets. Subnets are logical subdivisions of our private network. For instance, we could split the VPC in the middle and create 2 subnets that have exactly half of the addresses available each. But why do we need to partition addresses within our private network? The reasons can vary, but the idea is that we logically group resources together. For example, we could say that the top subnet is for data persistence and is not directly exposed to the internet, whereas the bottom one contains our web servers, needs access to the internet and to the other subnet in order to access the data. We could also split the VPC 4 ways by using smaller subnets, and you don't have to use up all of the addresses available in the VPC. Finally, subnets don't have to be of the same size. Okay, we're going to create two subnets and call them A and B. When you create a subnet, you provide a name. We've got that. A CIDR block, we have that for each of the subnets on the top left, you can see. Which VPC it should live in, we've got that as well, is the VPC we're creating. And finally, an availability zone. An availability zone is an isolated location within a region. For instance, as of 2018, the Ireland region has 3 availability zones. Back in the dashboard, we're going to click on subnets and create a subnet. We'll give it a name, my subnet A. Notice it's actually optional, the name, but it's good practice to give it a name so it's easily spotted. We've put it in our VPC availability zone A, and we'll give it the CIDR block that we've decided earlier. Click create, and that's about it. That's created. Let's do the same again for B. Call that my subnet B. Put it in the VPC that we're creating. We'll give this availability zone B, and finally the other CIDR block, which is the addresses starting from 64. Click create, and that's it. We've got 2 subnets in the VPC we've created. There they are. And notice that there are some existing subnets here. They're the ones that come by default with the default VPC. Right, we have our 2 subnets. Let's talk about Internet Gateway. When you create a brand new VPC, there is nothing connecting your private cloud to the public internet, so nothing can come in or out of the VPC. With an Internet Gateway, we connect the VPC to the public internet to allow traffic in and out of the VPC. So let's create one. I'm in the VPC dashboard. Go to Internet Gateways. You can see there's already one for the default one, but we're going to create a new one. Let's just call it my Internet Gateway. Hit create and close that, and you can see that it's been created, but it says it's detached. That's what happens when you first create it. You just have to then associate it with a VPC. We'll just pick our own, and here we go. So it's been created and attached to our VPC. Done. Moving on to route tables. Route tables prescribe how traffic is routed to and from a subnet. Each table has rules, called routes, consisting of a destination and a target. By default, any route table has a rule to allow traffic within the VPC. In the VPC we're creating, that's a destination block, which is all of the private addresses, and the target, which is local. Another route that we can add is for anything trying to reach the public internet to be routed via the Internet Gateway. The destination block in this case is 40/0, which means all of the internet, and we select the Internet Gateway as a target. When a subnet has this rule, we call it public, making subnets without a route to the Internet Gateway private. We're going to leave subnet B as private. With the rules we've laid out, if a node in subnet A wanted to send data to subnet B, we have a route to allow this. A node in subnet A can also reach out to the internet using the second rule we've added. But if we try to communicate with the internet from subnet B, then that would not go through as there is no route to allow it. Each VPC comes with a default route table, which is attached to all subnets unless you create your own and then associate subnets to it. Every subnet has to have a route table, and it can only have one. However, a route table can be associated with more than one subnet. Okay, we're going to create 2 route tables, one that allows internet traffic and another that doesn't. We're in the VPC dashboard. Let's go to route tables, and you can see that there's already a route table in our VPC. It has a rule to allow internal traffic, so that's traffic to and from our subnets within the VPC, and our 2 subnets have been associated with our default route. But we want to create a new one. We'll call that my route table A, And yes, this is what we want in our VPC. So let's create it. And once that's done, we're going to want to add a new rule. So we'll make this one be accessible from the internet. So we'll add the 0.0.0.0/0 destination, which means all of the internet, and select the internet gateway as a target. Click Save, and then we also need to specifically associate our subnet A to it. Okay, let's select that, hit Save, and that should be it. We've created our route table that allows internet traffic, and we've associated subnet A. So we've made subnet A public. You can see that there. And you can also see that our default route table only has subnet B on it. Let's create another route table. We'll call that route table B. And by the way, you don't have to have one route table per subnet. This is just one way you could have it. And we're happy with the only rule that there is. We only allow internal traffic, and all we need to do is just associate subnet B to it. So let's hit Save, and you can now see that there is nothing associated to the default route table because subnet A is associated to route table A, and the same goes for B. That's it. We've created two route tables, and we have associated our subnets to those two. Right, security groups. A security group acts as a virtual firewall for any node you have in the VPC. In other words, it decides whether data is allowed into a node or not. The same goes for data coming out of a node. A security group is a list of rules for inbound and outbound traffic. By default, no traffic is allowed, so we add rules to enable traffic. For inbound traffic, a rule consists of a source, protocol, and range of ports. So if there is a data packet coming in, the security group will check the address it comes from, as well as the port and protocol, to see if any of the rules allow it. For the outbound rules, the only difference is that we have a range of destination addresses instead of source. We're going to create a security group that allows inbound traffic over port 22 from all of the internet, that's 40/0, over TCP, and outbound to any internet address over any port. So back in the VPC dashboard, let's go to security groups. We can see that there's a default one that comes with a VPC when you create one, but we'll make a brand new one, call it SG-1, and we'll give it a description of demo security group, and making sure that it's in the VPC we created, and hit create for the security group. And there it is. So if we select it, we can see that the outbound rules, that there is a rule already to allow all outbound traffic, but we want to add an inbound rule on port 22 to allow basically a CIDR block, which is all of the internet. So we'll give a description allows SSH from anywhere. Hit save. That will add the inbound rule, and we're done. That's our security group. Let's look at what we've built so far. We've created our own private cloud with two subnets, an internet gateway, two route tables, and the security group. The final element we're going to look at is network access control lists, or NACL. Like a security group, they're similar to a firewall in deciding what traffic is allowed in and out. Rules are very similar with source addresses, protocol, and port range. But you can specify whether the rule is to allow or deny the traffic described. You also have to specify the priority order for the rule. Unlike a security group, they operate at the subnet level. A subnet has to have a NACL, so whenever you create a subnet, it is associated to the default one. Rather than creating a new one, I will just show you the one that already exists in our VPC. Back in the VPC dashboard, we're going to click on Network ACLs. You can see that the default one is there for our VPC, and the subnets that we've created by default were associated with it. Let's look at the inbound rules. You can see that traffic from anywhere, which is the 40/0, is allowed, and that's got rule 100. And similarly, there's the same rule for outbound traffic. All right, now that we have our custom VPC, let's actually move some data in and out of it. We're only going to use the public subnet, the one that we called A. We will deploy an EC2 instance within that subnet and apply the security group that we created to it. We'll then connect to it using SSH and start a server listening on port 4242. Trying to send data via this port should not work because our security group SG1 only allows traffic from port 22. Finally, we update the security group to include port 4242 and we should be able to get through to it. Let's take a look. Back in the console, we're going to the EC2 dashboard. Then we want to launch a new instance. We're okay with the top image as well as the pre-selected instance type. Want to make sure that we deploy it in our VPC in the subnet we decided, which is subnet A, and we want to enable auto-sign public IP. Move on to the next screen. We're going to leave this as it is, as well as the next one. We're not going to add any tags, and then we'll want to select the security group we made earlier. And there's a note there about the fact that our security group allows any IP address in the world, which is right. This is just for a demo, but try and keep it as close as possible. And here we're creating we hit launch and we're creating a new key pair that we're downloading, and then hit launch instances. I'll tell you in a second what that key pair is, and then we can see that the instance is now launching. The instance is now running. Let's copy its public IP address to the clipboard. We'll use that when we SSH into it. And this is just to show you the key pair that was created when we launched the instance. We had AWS generator key pair. The public key is stored in the EC2 instance, and the private key we downloaded earlier, and that's going to let us SSH into the instance. We're in a terminal, and the first thing that we want to do is to reduce permissions on that private key that we downloaded. So here's the command chmod 400 and wherever the private key is. And then we can SSH, and we can, the -i is the flag to supply our own key. We want to use the one we downloaded. And then we want to log in as EC2-user and paste the public IP address here and say yes, we trust this host, and we're in. To send data from the computer I'm using locally and the EC2 instance that we've created, we're going to use a utility called netcat. Netcat can both run as a server, so it waits for someone to connect on a certain port, but also it runs as a client. So I'll just show you locally how that works. So I'm going to run netcat locally. So I'm listening on port 4242 on my computer, and then in a separate terminal session, I'm actually going to connect to it, and you can see that that the server is receiving data, and if the server sends data back, the client also gets it. And we're going to do the same, but we're going to be running the server from the EC2 instance. So back in the SSH session with the EC2 instance, we're going to first install netcat. The operating system that we've selected, Amazon Linux, uses YAM, so that's what I'm using here. And then we're going to start netcat on port 4242, like we've done locally earlier. So then if I go on a different session, and this is just from my local machine, I'm going to try and connect to the public IP address of the EC2 instance and send something, but doesn't look like our message made it through, and there's no data coming back either. So this is happening because the security group that we've applied to the EC2 instance doesn't allow port 4242. It only allows port 22 at the moment, which is how we're SSHing into it, but 4242 is not allowed, so we're gonna go change that. From the VPC dashboard, we want to go into our security groups and get the one that we've applied to the EC2 instance and change the inbound rules. We want to add port 4242 over TCP, and again, this is not best practice, but we're just gonna open it up to the whole of the internet just to keep it easy and straightforward for this demo. So save that, and that's it. Let's go back to it and see if it if we can communicate now. Back in the SSH session with the EC2 instance, just notice that at the bottom I have two different tabs, and one is for the remote session, which is me SSH into the EC2 instance, and the other is just my local machine. So I'm just going to start Netscat remotely, and now we're on the local machine. We're going to connect to the IP address and try to send a string to it. Did it work? Let's see if that worked. Yes, we can see here that we can communicate back and forth, and opening up the security group lets data come through. Awesome. Before we wrap up, let's destroy all of the resources that we've created for this demo. So starting from the EC2 dashboard, we want to terminate the instance that we created for this. So I'm going to select terminate there, confirm, and this will take a while. And once it's destroyed, we can then go ahead and also delete the VPC. So select your VPCs and the one that we created for this demo, and just say yes, delete, and that will actually take away all of the things that we created inside of the VPC. Okay, we made it. In this video, we looked at the fundamental concepts of a VPC. I hope it was helpful. If you have any comments or feedback for me, please reach out on Twitter. Bye!